Hello everyone, myself Dr. M. Pavan Kumar Reddy, Assistant Professor, Department of Mathematics, VNR VJEC. Today we learn change of variables in double integrals. That is how to change variables from one coordinate system to another coordinate system and evaluating the integral. So we have a special case in that only Cartesian to polar coordinates. So Cartesian coordinates, the variables are xy as we know, and polar coordinates, the variables are r and theta. So how to convert a double integral which is given in Cartesian form to polar coordinates and evaluation. Okay. See, for double integral in Cartesian coordinates which is given in terms of xy, the change of variables to polar coordinates r and theta, we use this transformation. This is the transformation we use Cartesian to polar. So x is the variable in Cartesian coordinates, x and y are variables in Cartesian coordinates, r and theta are variables in polar coordinates. This is the transformation we use. X and y expressed in terms of r and theta. X equals to r cos theta and y equals to r sin theta we take. Okay. And so what is this Jacobian? So while transforming from one coordinate system to another coordinate system, this is double integral over r f of x comma y dx dy. Okay, instead of x, you are substituting r cos theta. Instead of y, you are substituting r sin theta. Now, dx dy is nothing but it is Jacobian into dr d theta we have to consider. What is this Jacobian? Jacobian is a Jacobian of the variables x and y with respect to r and theta. What is actually the Jacobian? Jacobian is a determinant of the partial derivatives. Determinant of partial derivatives. So, partial derivatives of x and y with respect to r and theta. Okay. So, here first we determine the Jacobian. Jacobian of xy with respect to r and theta. So, it is, we can also represent the Jacobian in this form. Dou of x comma y by dou of r comma theta. You can pronounce it as del also. Del of x comma y by del of r comma theta. Which is, since you have two variables in two variables, so that's why it is the 2 by 2 matrix determinant. See, the elements in the 2 by 2 matrix are, so first row are the partial derivatives of first variable with respect to the variables r and theta. So, first row is partial derivatives of first variable x with respect to r and theta. That is dou x by dou r, dou x by dou theta. Second row are the partial derivatives of y with respect to both r and theta. That is dou y by dou r, dou y by dou theta. Okay. So, determinant. Okay, determinant. What is dou x by dou r? X derivative with respect to r. Remember, we are differentiating x with respect to r, partial differentiation. While differentiating partially with respect to one variable, the other variable is treated as constant. You are differentiating with respect to r, let's treat cos theta as constant. R derivative with respect to r, 1. So, dou x by dou r is cos theta. Next, dou x by dou theta. Dou x by dou theta. We treat r as constant this time, and cos theta derivative with respect to theta is cos theta derivative minus sin theta. Minus sin theta. That's why it is minus sin theta. Similarly, the partial derivatives of y with respect to r and theta. So, y derivative with respect to r, dou y by dou r, we treat theta as constant, and r derivative with respect to r is 1. Okay, next y derivative with respect to theta, we treat r as constant, and sin theta derivative with respect to theta is cos theta. So, this is sin theta r cos. What is we know? Simple determinant. Determinant of 2 by 2 matrix is AD minus BC. If A, B, C, D are the elements in the 2 by 2 matrix, AD minus BC. AD cos theta into r cos theta. That is r cos square theta minus sin theta into minus r sin theta. Minus into minus plus r sin square theta. If you take r common, we have cos square theta plus sin square theta. As we know that cos square theta plus sin square theta is 1. That's why the Jacobian of xy with respect to r and theta is r. So therefore, now the double integral in Cartesian to polar can be represented in the form. So double integral over the region R. This is the region R in Cartesian coordinates. F of x comma y dx dy. Instead of x, put r cos theta. Instead of y, put r sin theta. That is f of r cos theta, r sin theta. See, you are changing Cartesian coordinates to polar coordinates. The region also may vary. So that's why the region I am denoting in polar coordinates is r star. R star is the region of integration in polar coordinates. So x equals to r cos theta, y equals to r sin theta, and this is Jacobian into dr d theta. So now if you substitute x equals to r cos theta and y equal to r sin theta, this integrand completely becomes a function of r and theta. Okay, let us denoting this one with capital F of r comma theta, okay, into r dr d theta. R dr d theta. So like this we change a double integral from Cartesian coordinate system to polar coordinate system. Okay. Now how we evaluate by changing to polar coordinate system? We see a problem. See. So evaluate integral 0 to infinity e to the power of minus of x square plus y square dx dy by changing to polar coordinates. Hence show that this one. First evaluate this integral by changing into polar coordinates and also evaluate this integral. Okay. Now see here. See. Consider this integral. This is. Consider, let us denote it with say some I. I is equals to integral 0 to infinity e to the power of minus of x square plus y square into dx into dy. So now to change it into polar coordinates, what is the transformation we are using? First anyway, identify the region of integration in Cartesian coordinates. So both x 0 to infinity, 0 to infinity, both the limits of x and y are 0 to infinity only. What is the meaning of x0, x infinity? X is equals to 0 means y axis. What is the meaning of x equals to infinity? X is equals to constant is a straight line parallel to y axis. X equals to infinity. Infinity means it's a largest number which is not defined. Okay. So it's a number which is parallel to y axis. We cannot draw on here. Similarly, y axis means y equals 0 means x axis, and y equals to infinity is a straight line parallel to x axis. So means that the region of integration here is the entire first quadrant. The region of integration here is the entire first quadrant. So R is the region entire first quadrant. Entire first quadrant is the region of integration. Okay. Now converting it into polar coordinates, the same region, how to identify the limits for r and theta? Generally in the region what we do, we consider, in case of Cartesian we consider a strip, horizontal or vertical strips, but whereas in case of polar coordinates we consider an angular strip, that is with some angle. This is with some angular thickness. We are considering a strip in the region of integration. So this is the strip I am considering in the region of integration. So where the strip has its ends, one end is at origin, which is pole, which has the distance from pole is 0 units. So r equals 0. Where is the other end of the wedge strip is moving, which is infinity, entire first quadrant. There is no limit. So r is equals to infinity. And to cover this region, this strip has to move from the line, initial line theta is equals to 0 to theta is equals to pi by 2. Theta is equals to pi by 2. So here to convert it into polar coordinates, we use the transformation. Let x is equals to r cos theta, y is equals to r sin theta, and dx into dy is equals to r into dr d theta. R into dr d theta. And here the corresponding limits for r is, r varies from 0 to infinity and theta varies from, it is 0 to pi by 2. Since the entire first quadrant means which lies between the lines theta is equals to 0 and theta is equals to pi by 2. Okay. So these are the limits for both r and theta. Now this is this integral I which is equivalent to, it is integral. Okay. First let's substitute x is equals to r cos theta and x is equals to y is equals to r sin theta. X equals to r cos theta and y is equals to r sin theta. What is the integrand we have? Now what is that? It is x square plus y square. What is x square? R square cos square theta. Since x equals to r cos theta plus x equals y equal to r sin theta. So r square sin square theta, which is r square common, cos square theta plus sin square theta is 1. So therefore the integrand becomes now e to the power of minus r square. So therefore now I, which is equals to integral theta varies from 0 to pi by 2 pi by 2, r varies from 0 to pi, 0 to infinity. Zero to infinity, and e to the power of minus, see, x square plus y square equals to, as you know, it is r square into dx dy equals to r into dr into d theta. Okay. Now, anyway, so first we integrate with respect to r and then with respect to theta. So now, how to evaluate this first with respect to r? Let's make a substitution. So let us take, let r square is equals to, I am using substitution t. Then it is 2r into dr is equals to dt. Let's differentiating on both sides. So just we need r dr. We have r dr here. Keep r dr and bring to other side, dt by 2. And what are the limits? Since we are using substitution r square equals to t, so we have to determine the corresponding limits for t also. Now what are the r limits we have? When r is equals to 0, t is equals to, see, if you put r equals 0 here, t becomes 0. And if you put r is equals to infinity, then t becomes obviously infinity. T infinity, it is infinity. Okay. So now if you substitute here, which is equals to integral theta varies from 0 to pi by 2 and e power minus r square. Now this becomes t is equals to 0 to infinity, e to the power of minus t, since r square equals to t, r dr equals to, what is r dr? Which is dt divided by 2 into d theta. Now let's evaluate this integral. Now this is equals to, which is now integral theta varies from 0 to pi by 2. Okay. It is 1 by 2 can be written outside. So 1 by 2 outside. Next, integral t varies from 0 to infinity, e to the power of minus t into dt, and finally with respect to theta, which is equals to 1 by 2. Integral theta varies from 0 to pi by 2. Now integral e power minus t. What is integral e power minus x? E power minus x integral is e power minus x divided by minus x derivative in the denominator. Minus x derivative is minus 1. So upper limit infinity, lower limit 0, it is d theta. This is equals to 1 by 2. Integral theta varies from 0 to pi by 2. Substitute the limits. Instead of t minus infinity, e power minus infinity divided by minus 1, minus substitution of lower limit, e to the power of 0 divided by minus 1 into d theta. What is actually e power minus infinity? E to the power of minus infinity is 0. Okay. So integral theta varies from 0 to pi by 2. So upper limit has no contribution, minus into this minus plus e power 0 1 into d theta. This is equals to 1 by 2. Integral theta varies from 0 to pi by 2, integral 1 d theta. Let's evaluate this integral. Now it is integral 1 by 2 integral 1 d theta is theta. Upper limit pi by 2, lower limit 0. That means this is equals to, which is I is equals to pi by 2 into 1 by 2. Pi by 2 minus 0. Upper limit is pi by 2, lower limit 0. So it is equals to pi by 4, which is I. What is actually I? I is equals to, see, I is equals to integral 0 to theta equals 0 to pi by 2, r equals 0 to infinity e power minus r square. We'll do one thing. Let's take this is, don't consider this as I. Just consider this integral. Therefore, integral 0 to infinity e to the power of minus of x square plus y square into dx dy. This is equivalent to this one. This is equivalent to this. So now, see, this is now we got pi by 4. See, it is integral 0 to infinity. Therefore, integral 0 to infinity e to the power of minus of x square plus y square into dx into dy or dx dy, which is equals to pi by 4. This we got. Now, what we have to prove is integral 0 to infinity e power minus x square dx equals to pi by 2. Integral 0 to infinity e power minus x square dx equals to pi by 2. So, in order to prove this one, okay, let's consider that, see here, consider I is equals to integral 0 to infinity e to the power of minus of x square plus y square into dx into dy. This can be written as integral 0 to infinity. See, in both the integral limits are constants. You can write this integral as first, this is 0 to infinity. This can be written as e power minus x square into e power minus y square, correct? This is dx into dy. Okay. So, integral 0 to infinity, okay, this is e power minus x square into dx into integral 0 to infinity e to the power of minus y square into dy. Since both the integral limits are constants, okay, we can write the integrals like this. Okay. And also here integral 0 to infinity e power minus x square into dx into integral 0 to infinity e to the power of minus x square into dx. Since the integral limits are constants, you can change it to any variable. Suppose if I substitute instead of y here x, y becomes x, dy becomes dx. Limits become same. Y limit 0 to infinity, x limit 0 to infinity. That means if the integral limits are constants, you can use any variable instead of that. So I am changing y to x. This is. Now if these two, product of these two integrals can be written as now. This is now equals to, it is integral 0 to infinity e to the power of minus x square into dx whole square. We can write it as integral 0 to infinity e power minus x square dx whole square. What is actually this I value? I is 0 to infinity e power minus of x square plus y square into dx dy. Let us take it as an equation number 1. Okay. Okay. Now, what is this? 0 to infinity e power minus of x square plus y square dx dy equals to pi by 4. So, you can substitute this equals to pi by 4 now. This is equal. This and this both are equal, and no, this we simplified this only, we got this. So, which is equivalent to now, which is pi by 4. Let's apply square root on both sides. So, therefore, integral 0 to infinity e to the power of minus x square into dx is equals to root pi divided by 2. Root pi divided by 2. Integral 0 to infinity e power minus x square dx equals to root pi divided by 2. Okay. Sorry. Actually, this is some printing mistake. This is actually root pi. Root pi. This is, we have to show that integral 0 to infinity e to the power of minus x square dx equals to root pi by 2. It is root pi by 2. Okay. So we used the transformation x equals to r cos theta, y equals to r sin theta, dx dy equals to r sin dr d theta, and substitution, and identify the region of integration here, and identify the corresponding limits for r and theta, and evaluate the integral. Okay. And see, in order to show this is equals to this integral 0 to infinity e power minus x square dx equals to root pi by 2. So as consider this integral, which is pi by 4. Okay. This is pi by 4. Okay. I equals to nothing but pi by 4. So this can be further simplified as, so e power a plus b can be written as e power a into e power b. Okay. So and these both the integral limits are constants. You can write integral a to b f of x dx into integral c to d f of g of x dx. Okay. And integral limits are same. You can change the variable also. Instead of y, you can take x, t, u, whatever you want to. Okay. So both are same. So square. And this is equal to pi by 4. Square root apply on both sides. We get this is integral 0 to pi infinity e power minus x square dx equals to root pi by 2. Okay. I hope you understand. So work out these problems by evaluate these integrals by changing into polar coordinates. Okay. Thank you. So for any queries, contact me over the mail pavankumarreddy_m@vnrvjit.in. Thank you.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.